In this Grasshopper tutorial, we want to model a mechanism in Grasshopper, and the mechanism is basically a circle you can see here, which is going to move up and down, and there is also a series of linkages that connect to this circle, and they are confined on this circle. So by changing the secondary circle, you can see that if I move it here, we can make something like this. And if we move it too much, it's going to give you nothing. That means that the mechanism is going to fail. So the maximum movement is going to be up like here. So this tutorial is going to help you to see, by changing the size, I can increase the first radius. This is the circle radius, the first circle. You can see it's going to go inside if we make that smaller. And then we can just also change some of the parameters. The first parameter is the rotation, which I'm going to explain in this tutorial. Be sure to watch the video till the end. And also the length. These are going to help us to produce different results. For example, if I make this a bigger one, you're going to understand. This is the length, which you can see it's going to affect the linkage, the rotation, and this is going to give us different results. So you can see if I move that up and down, this is going to be one of it. If I change the length, make this smaller and increase the rotation, you can see that we don't have results there, but now we will have it. We will have that. And maybe we can increase the length, the rotation, and then by moving it up and down, we can see what's happening here. So that is how the linkage is going to work. We can also change the number of the counts. Maybe we just want to make it like a table, and then we can move it up and down. So it's a completely mechanism table. It can go up and go straight, something like that, and then it can go down and be closed like this. Like this. We can also change the radius so it makes sense. So this is also a new mechanism, and I can move it up and you can see the results. Again, it's going to break, but you can see that. Okay, so this tutorial is going to help you understand how to find the location of this mechanism. The first circle is not really important. The second one is really important because that's going to define how it's going to move up and down, and we can control everything. So be sure to watch the video till the end. Subscribe to our channel because we have weekly tutorials on Grasshopper, and like this video, because liking this video will really help us with our YouTube channel, because it's going to show you more of our videos and it's also going to rank it better. Also, if you want to learn Grasshopper step by step, we have a course. I'm going to put up the lessons and example files up here so you can check that out. Or you can go to powercourse.com to enroll and learn Grasshopper. We have weekly tutorials. So let's get started from scratch. I'm going to put the new document here and do it from scratch. First of all, what I want to do is to talk about the circles. So we need two circles here. First is the location of the base circle, which is fixed. It's completely fixed. And the second circle is the location of the mechanism. You can see that this is the location of the mechanism, which is fixed and it's not going to change. The only thing that is going to change is the rotation of these two rods, because they can move, and this is a free mechanism, so it's going to rotate around this one. So let's make this happen by making two circles in Grasshopper. That's really easy. Curve, and I'm going to use this circle. I'll put the bifocals plugin so you can see what I'm doing. And we need two circles, so I'm going to just Control-C, Control-V from 1 to maybe 30 with 2 decimals, and this is like radius 1, and this is like radius 2. So I'm going to give this with 2 circles. Maybe we want to make that bigger, so I'm going to increase the radius. Okay. That's the loop we want to have a fixed one. For example, I'm going to give this a surface, a pipe, so you can see that this is basically what we want to do. Okay. What's going to happen is that in this mechanism, and it's really important for us, is that this is going to move up and down. So you can see it's really a simple mechanism. It's going from the ground up. So we need something here to move this circle a little bit up. I'm going to say MV move and move this circle in the Z direction. That's the movement. And give this from 0 maybe to 100, 2 decimals. This is going to move this up and down, right? Maybe a 30 is enough. So this is the first thing we have to do. It's going to move up and down, right? The next part is that this linkage, it's going to be confined on this point and also this point. So these points are not going to change, but this point here is where is the location of this point? Where can we find it in space? And actually, this is really obvious. This point can't move in the y direction. I mean, let me just move this up. You can see that this is in a complete plane. That is the reason we're going to only find this on one of these lines and then simply put an array on the final results. So let's just simplify this mechanism into one only linkage we want to work with, and that is only here. Okay. Now what we have to do is to study the linkage, how it's going to rotate and move. For example, if we had a linkage like this, let me bake these two circles in Rhino, so we will have these in Rhino. We have two fixed points. This is the first point, this is the second point. And for example, I'm going to draw a linkage like this. The first one is going to go up like that, and then going to go here, okay? You can't have a straight line because it's not going to open. Up is going to break. So you have to have something like this happening, okay? That's it. Now we have this point also here. If we move this circle a little bit up, I'm going to have it like here, for example. We will have this point again fixed here. And now we have to find this point in space. How can we find this in space and find the rotation of these linkages? It's really easy. First of all, we have to draw a circle from this perspective of, if you look at it from this point, it's going to be a circle in space, right? With this radius. So it's going to be R1. And again, if you look at from here, it's going to be a circle from R2. So it's going to intersect, and then we will have that results. So what I want to do here is to draw a circle from this length. I'm going to type length. It's going to give me this number, and then I'm going to draw a circle, a vertical circle from here. The number is going to be like 15.943. I'm going to draw the circle like that. Again, draw another one, length, and draw a circle, vertical, and we have to type it like this. It's like 13.45. Okay, that's it. It's going to give us 2 points, so actually it's obvious that's going to be the upper point. So we dismiss the point, the down one. So I'm going to delete this, and it's going to be like this. That is going to happen if we just make a polar array from this on the center, like 12 of these happening. This is going to be the mechanism. You can see that this is going to move from here to here. So let me just show you with this one. A polar array from 0 with 12 of these. This is going to move it up like that. So it's going to move from here to here with this mechanism. This is the best method to find the solution in Rhino. Play a little bit with static parameters, because we're going to go to Grasshopper and use dynamic parameters, because they are going to change, right? So now we know the solution. We have to make that in Grasshopper. Okay, let's go and make a curve and a circle again. We have to give this an XZ plane. That means an XZ plane for the circle. So I'm going to say XZ plane. Okay, this point is going to be always fixed. So what we want to do is to go to the curve and use this point on curve tool. Give it to the second circle and make it 0. That means the first point. And give it to this. Okay, now we have the circle. Let's define the radius. I mean, if we had this linkage, right, we have to define R1 and R2. So that's all what we have to do. Let's define length for this R1. So I'm going to say maybe from 2 to 25 with 2 decimals. And you can see that this is the first length. Okay, go here and go to the curve and use this line STL. Okay, let me explain. We're going to draw a line from here. The length is obviously the same of the radius, but we want to give this an initial position for when it's down, right? So what I want to do is to give it a direction. That's really cool. What I want to do is to use this technique. I'm going to use the direction X and then rotate it around Y and bring it up. So I'm going to say X rotate with this one, rotate a vector around an axis. Okay, the axis is Y. Now an angle, I'm going to right click and put it into degrees, maybe 0 to 180 with 2 decimal. Okay, let's give that to the direction. And you can see that it's going here. So instead of the X, I'm going to go minus X. So let's just go to the expression and the factor, expression minus X. It's going to fix that. Okay, that is going to help us to define the initial rotation. So that is the initial rotation we have. And now the second length, which I have explained there, it's going to be fixed. Connect here to here. This is going to be actually the second arc. So we're going to define everything with this. I'm going to make it in red. R1, a degree, which is going to be here, and then movement in the Z direction. That's going to define everything. So let's just do that. I'm going to go to the curve, point on curve, put it at the end, and draw a line from here to a point on the circle on the ground. So let's just go here and give it another point on curve. I'm just doing this because I want to show you the connection. This is actually the initial connection. So this is going to define the linkage. This is also going to define how it's going to be the size. That's it. Okay, now that we have the length of the second, we're going to do that second circle again up on the circle which we moved. So remember that we have to also copy the point on curve. So I'm going to just copy this up, give it to the moved circle. The radius is going to be the length. I think that if I give this line to the radius, it's going to understand. Okay, that's great. So you can see that this is also the second circle. You can see that they are not intersecting because we have moved that too much. So I'm going to just move it a little bit down. You can see that this is intersecting. If it's moving up too much, it's going to break. So if we put it here, if we change the size of the length and the degrees, you can see that we have more space to play with this movement. You can see that it's going to move much up, much higher. Okay, now we have to intersect these two circles together. So I'm going to go to the intersection and say this too. Intersection with the curve. Now we have this circle move up, the first circle, and the intersection. Okay. And now you can see that by moving this up and down, this is also moving. What we have to do here is to choose between one of these 2 points. Okay. If I select the sets and list item to pick up the first one, you can see that that's not right. So I'm going to reverse the list. And you can see that we have selected this as the first point. But there is a problem. If I play with these circles, sometimes that's going to be, if we play with this, I want to show you that this is going to be sometimes an error. So, if you have some problems with selecting the first one or the last one, the problem is sometimes the algorithm is going to switch between this one. It's going to ruin the algorithm. So let me just finish this with this reversed list and then show you what is going to have some problems, and then we're going to fix this small little tiny definition. So I'm going to draw a line again. The first point is going to always be on the circle, like here. And the second point is going to be like this. Okay. And the next one is going to be from this point to the point we had down here. I guess it's like this one. Okay. That's it. And now we have to join them together. So I'm going to go to the curve utility and use this join curve. Use the shift key to add them up. It's going to make it like one polyline curve. And then we can go to the array transform and use this array in polar array. So I'm going to use that one. The center or the plane is like here, so it's okay. The count can be from 3 to maybe 12. The angle is 2 pi, so it's okay. It's like 360 degrees. Let's just change and play with this. So you can see that I'm increasing. We can also turn off the space circle. Okay, now let's play with this. Up and down, up and down. The length, the rotation, initial rotation. This is going to give us different results. And the circle. If I make this too small, with this one, change it. Especially with this initial length. You can see that this is going to change everything. Movement too much. So let's bring this down. Okay. I just wanted to show you some of the problems we will see if we move that. Oh, okay. That's it. That's exactly what I wanted to show you here. Okay. We have to fix this. Look at this. If I move that from here, these are not. Sounds something. There's a problem here, right? If I move that up too much, you can see down, down, down. It's going to break. So what is the problem? The problem here is with this list item we had used. So how can I fix this? Let me just put this as a point. Give it a point container from params geometry point and give it to these 2 points. Delete this. And let's talk about these 2 points. Okay? How can we say that in every condition, pick up the point which is higher in the z direction? That's going to be to go to the vector and deconstruct the point. So I'm going to deconstruct these 2 points. Then I'm going to sort these points from minimum to maximum. So I'm going to say sort these. Okay, let's just bring this a little bit forward. So it's going to sort this from minimum z to maximum z. Then I'm going to sort these points based on this sorting of the z components. So this is going to give us the point with lower z and the higher z. Now we can pick up the list item and say we need the second one, which is the higher one, right? This is going to be used in any condition. So that's it. That's going to give us always a correct result. You can see even if I bring this down, it's going to be always the correct answer. That was the trick I wanted to teach you with this little deconstruction, sorting, and that's it. So now we can play with this initial length, the rotation, the circles. It's really cool. You can see that we can produce different results. And now if I move that up and down, it's going to give us something like that. Okay. For those who have watched till here, I want to give you also another trick. How can we show these lines like that? So I want to explain how we can use this pipe things, and if you want to make it like this, it's going to be a good visualization of the mechanism. So how can we do that? The way I'm going to do this is to use these lines, these polylines, and I'm going to go to the curve and select this explode thing. I'm going to explode that. You can see that we have segments here. Because I don't want them in groups, you can see that we have 9 groups of 2. I'm going to flatten this. If you don't know about flatten a graph, I'm going to put up a tutorial related to this. So I'm going to just flatten this. Okay. Now we have all of these lines, 18 lines here. Okay. To make this obvious, if we had a line here, what I want to do is, and also another line here. Okay. I'm going to evaluate this line based on a length. For example, L here, and also at the end, L here. You can also evaluate from here and here. What's going to happen is that we can draw a circle or sphere with a radius of L here, and then pipe that second line to make it like a joint. So this is the technique I'm going to use. Go to the curve, analyzes, and we have this evaluate length. Remember it here. Be sure to put this normalized to false, because it says if you put it normalized, you can see it's going to make it from 0 to 1. We don't need that. We need exactly the length. So I'm going to just go to normalized, set to false, and now give it a length 1.25. So this is the length, you can see it here. Then we have to also evaluate it from the start. So I'm going to go to the curve, utility, and flip the curve. Again, evaluate the length exactly. And this is the technique you can use to evaluate the length from start and the end. Then we can connect it with a line. Turn everything off. And that is going to give us an offset from the start and the end. Okay. If you want to make it a pipe, you can go to the surface and just use this pipe thing here. Give it a radius. That's it. Okay. You also need to draw spheres. So I'm going to go here and select the vertices and put it. Flatten this so it's all in one point. If we have duplicate points, I'm going to go to the vector point and use this called duplicates. It's going to delete those points. Let's check this out. If we have like, okay, just show me the numbers, 27. After that, it's going to be like 27. So we don't have duplicates. We are sure that there is no duplicates. We can go to the surface and draw a sphere. The radius is going to be the same as this length. Okay, this is a little bit slow. Let me show you what I mean. If I move this up and down, it's a little bit slow. How can I make it faster? Instead of using this one, you can also go to display, canvas widget, and I think it's like profiler. It's going to show you that this is a little bit making it slow. I'm going to go to the sphere of mesh. So the primitive of the mesh, it's going to be a sphere. The base is like this, the radius is like this. Let's play with these things and see that it's really faster. So that's the way you can do it. Now let's give this a little bit of a color. So I'm going to go to the display and give this a preview, a swatch. Usually give that to make it with colors. So it's black. Turn everything off. Give it another color to the pipes. Okay, and another color to the ring. We had it like here. Give it maybe red. Control the radius. That's it. And we can turn everything off. Turn on only the custom previews. So we are sure that we are not showing anything additional, and that's it. So now we have the mechanism. We can play with it and work with these numbers. The first circle, the second circle, the length, initial length, the initial rotation. If you want to understand exactly what's happening, just close it, bring it to 0 in the movement. So I'm going to just name it movement so you can understand this. And this is just a pipe radius. Not really important. Okay, this is exactly the initial location of the mechanism. So we can play with the initial length, with the initial rotation. And now we can see exactly what's going to happen if we move that up. Remember, if you move it too much, it's going to break based on different mechanisms. For example, if I bring this a little bit inside, and make this a little bit bigger, bring it down. Okay, for example, we have this mechanism. We want to make that circle, second circle, a little bit smaller. That's it. We want to make the initial length a little bit bigger, and the rotation, make it like this. Maybe we want to start something like this and then bring it up. What's going to happen? It's going to make it like this. Okay, they're going to intersect, so remember that you have to play with these carefully. Maybe just bring that a little bit back so they don't intersect when we bring them up. Okay, that's great. You can see that even if I increase the movement a little bit up, I'm going to get final results. It's going to break. So that's exactly the mechanism. Okay, I hope that this tutorial was useful and you enjoyed it. Remember, you can play with these radiuses, with this pipes, and make it like that. First pipe. Okay, I hope that you enjoyed this tutorial. Remember to like it and subscribe to our channel, and share it with your friends. See you next time. Bye.